Bond energies is an extra third alternative for calculating enthalpy changes for reactions that clearly don't require you actually having to conduct the reaction. So let's look at this second example. And in this one, I've got methane reacting with chlorine and fluorine. And I formed three new products, sorry. Again, realize that if I want to get the enthalpy change here, I'm going to figure out all of the energy that goes into breaking apart all those atoms of those three reactants. I'm going to add up all the energy that evolves when the new bonds form in the three new products, and the difference between them will give me the enthalpy change or the heat of reaction for this particular chemical reaction. So starting with the methane, I see that there are 4 hydrogens connected to the carbon, so I've got 4 different bonds I have to break. So that's what the 4 comes from, and each of those is a carbon-hydrogen single bond, and its value is 413 kilojoules. My second reactant, I have 2 chlorine molecules. There are 2 chlorine atoms in each molecule, but there's only 1 bond in each molecule, so there's 2 bonds total, and a chlorine-chlorine single bond is 239 kilojoules. And going finally to the third reactant, I've got the fluorine molecule. Again, I've got 2 of the molecules. There's 2 atoms in each molecule, but there's only 1 bond that hooks up the 2 fluorine atoms. And a fluorine-fluorine single bond is 154 kilojoules. When I add up those 3 products, I will have the energy that had to be put into the system to separate all the atoms. Now let's look at the products. I go to my first molecule, my first product, the CF2Cl2, and you've got to be able to look at a formula and know what atoms are connected to what. And clearly here, carbon is in the center, and the first thing I have to do is pull 2 fluorines off of that carbon. So there's 2 carbon-fluorine single bonds worth 485 kilojoules apiece. There are also 2 chlorines connected to that carbon. Remember, carbon likes to have 4 bonds. So there's 2 carbon-chlorine bonds that need broken. Each one is 339 kilojoules. So those 2 terms represents the energy that will evolve as those 4 bonds form, the 2 carbon-fluorine single bonds and the 2 carbon-chlorine bonds. Now we go to the second product, and we've got hydrogen fluoride. I've got 2 molecules. In each molecule there's only 1 hydrogen-fluorine single bond forming, each one worth 565 kilojoules. And finally, my third and final product, my hydrogen chloride. There are 2 hydrogen chloride molecules, but in each one there is only 1 hydrogen chlorine single bond forming. Its value is 427 kilojoules. So let's get the product of each of these terms. And we go to the first bracket. There are your 3 products. Let's go to the second bracket. Here are the 4 products. We're going to add everything up. So that first bracket adds up to 2,438 kilojoules, representing the energy that went into breaking all the bonds of the reactants. And the second bracket, the 3,632 kilojoules, represents the heat being evolved as new bonds form. So once again, I'm getting more energy out than I had to put in. That makes this an exothermic reaction, and the enthalpy of the reaction, or the heat of reaction, is negative 1194 kilojoules.